All right, in this video, we are going to see if the famous 5-minute FUSOR will actually create a plasma after 16 years in storage. So a lot of you have probably seen, specifically people who are interested in nuclear fusion and the FUSOR device itself, has seen the classic 5-minute FUSOR video. I will show you a quick little brief excerpt from the video right here. So since that video, which was made in 2009, I basically took it apart, mounted it in this stand, and it sat on a shelf until 2026. When right now, as we all know, it's January 2026. So here it sits. You know, look at all the dust on this. All right, that's 16 years of dust sitting in the shop. And so what we're going to do is we're going to break the epoxy that I used on the bottom here to kind of just mount this thing, and we're going to clean it up, and I'm not going to touch it. I'm not going to touch these epoxied end caps, because that's what the whole point of this. Can I make a FUSOR that holds enough vacuum with regular hardware store epoxy, similar to this? You know, you can get it at any hardware store. I believe this is JB Weld, but it's not what I used for this. I used some sort of really cheap $2 Loctite or something similar that I got from Ace Hardware to make this. Because there was a lot of discussion whether or not you can make a demo FUSOR, not a neutron producing FUSOR, a regular air demo FUSOR that can hold enough vacuum to make a plasmoid. So just to point a couple of things out. So this is where the vacuum or the epoxy was used to keep the vacuum intact. It was used here on the bottom to seal the vacuum connection. You can see it right here to hold the bottom against the glass. Same here on the top. And get rid of some of this dust on the top. You can see also where the high voltage feed through, which is alumina, was sealed also with the same 5-minute epoxy. Now, the video that we've all seen, I was able to energize that and make that video probably in less than maybe about 2 hours after I epoxied the whole thing together. So it worked. Will it work now? Here we are, 16, almost 17 years later. So let's go ahead and work on taking this thing apart, or I should say removing it from the stand, and hooking it up to a vacuum source, to a high voltage source, and see if we can go ahead and make some plasma with it. I'm of the frame of mind that this 16-year-old epoxy is going to do just fine, and I'm going to be able to get a similar plasma formation or plasmoid within the fusion grid. Other people have said that's absolutely not going to happen. It's already cracked and leaked, but we'll see. All right, let's move forward and remove this thing. So first thing I'm going to do is kind of clean this off so we can see what we're working with here. It seems to be holding up pretty good. It's not falling apart, that's for sure. All right, so be very careful. I do not want to break the seal, providing we still have a seal. All right, let's see if we can crack that off. Nope, that's not coming off. All right, so I'm going to get myself some, like a razor blade here, and see if I can get underneath the epoxy and see if I can slowly chisel away at this. And again, this is also 16 years old, so this thing's holding pretty good. I'm going to try to... This seam here, again, like I said, 16, and it's not coming off. So if it's this strong, I think the seal is good. So let's go ahead and start getting some of this stuff off so I can get underneath the epoxy with this razor. Oh, there we go. There we go. All right, that lifted up. Let's go ahead and lightly tap it with this jeweler's hammer. There we go. It's off. There we are. All right. Now, let's be very careful. I don't want to break any of the seals that might still be intact. All right, I think I might have an idea for cleaning that up a little bit. So one of the things I just discovered that I did 16 years ago, which is actually pretty good, is I put this rubber plug inside to isolate the atmosphere inside the chamber so no condensation got in. And if you can see, the condition of the grid is actually in very, very good condition. So there's no moisture, there's no indication of any contaminants other than the original deposition that you see on the inside of the borosilicate glass tube. So anyway, let's very gently get some of this old epoxy out. All right, so I'll work on this and I'll get back to you in a second. So I can tell you this epoxy is in pretty good shape. I've been kind of scraping at this for a while, and it's not decomposed or brittle. It actually even has some elasticity to it. So I mean, that's a good testament for the Loctite brand. But we'll see how it performs when we get into the vacuum portion of this whole experiment. Let's see. All right, let me just keep working on this, and because we're not going to make a video about scraping this crap out. We want to see this thing work or not. Okay, I think I got most of this out. Let's go ahead and remove this plug. There we go. All right, well, I might actually have to machine this a little bit because I'm going to do something kind of different to get this to work. All right. Stand by. So I took this to the lathe and I machined this down so it's nice and flat. And I no longer have the natural gas line that I used to hook this up for the original video 16 years ago. Funny, on that note, I actually did have the natural gas line that I used this all the way up to about 2 years ago. I was cleaning out the shop here and figured I'd never fire this thing up again, and ended up throwing the natural gas line out. So regardless, I don't have the original hookup, but I am going to use this modified version, and I'm not going to get in here to machine that out, and I'm not going to break the seal on this side because that's all part of the experiment. So what I'm going to do, and I think the vacuum is going to work, I'm going to make a flat rubber O-ring of sorts, like a washer. I'm going to put in here, and this is going to screw in like so, and it's going to compress against the washer and should give me enough of a seal to at least get down to probably 30 or 40 or so millitorr of vacuum, and provide a effect almost identical to what we had in the original video. So let's go ahead and make that washer. All right, so I made myself a little bit of kind of a crude junky washer out of some old rubber material that I got here. And yes, I'm going to be using huge amounts of tape on this. So here's the thing. Probably a lot of you guys are thinking, oh my gosh, look at these unconventional things he's doing. This is ridiculous. This is not, extremely high vacuum compliant, con-flat flange sort of stuff like maybe you got over here. That's the whole purpose of the 5-minute FUSOR. Hence, 5-minute epoxy. All too often, and I mean, people who know me, even in my past videos, I always complain about people that overcomplicate things and try to make life miserable for themselves by literally using electron microscope tactics to, you know, put together a project that doesn't require it. Anyway, so let's go ahead and put this in here. Okay, just like that. That looks good to me. And that's going to compress. I don't see that's going to be any sort of an issue. All right, that's going in nice and tight. So I will tighten that up a little bit later. And then I pick this up because the hose barb is going to fit. You know, actually, I'm probably going to connect the hose barb first. So let me clean the table off and we'll get to that point. All right, that fits in so like this. Let's go ahead and tighten that up a little bit. All right, that should do. All right, and I'll move the tripod just so you can see what's on the other end of this. So there we go. All right, get that diode out of there. And ever so gently, we will get this screwed in like that. Okay, that's good. So I will go ahead and get a wrench and we'll kind of tighten things up from there. Yeah, that's pretty tight. It's good enough for what we're doing. This I do not want to over tighten because that seal can only go so far, which I think I see the limitation right about there. There we go. All right. We might actually have to work on that a little bit, but I think things are looking good. Okay, so the vacuum pump is running. The gate valve is off. So I have no vacuum going to the chamber yet. We are going to test it real quick before we energize it. So I'm going to take a couple of precautions for me personally. I'm going to put on this face mask. And I'm going to also go ahead and just put that in there like that for right now. So let's go ahead and see how leaky this is. Now, I don't think the leak is going to be from any of the 16-year-old epoxy seals. The leak is definitely going to be from my, my crappy sort of connection points in this area. So let's go ahead. Now, we all know how vacuum pumps sound, so we'll be able to tell if it's really leaky or not by how much burping we hear, if it settles down or not. So here we go. Oh, look at that. I don't hear any burping. At least not much. That's good enough. I can tell you right now, I know it's leaky, but if it's not burping, we're going to have plasma. So let's go ahead and hook up the power supply. So one of the things that was nice about this small FUSOR design is it's self-rectifying. And that's a whole nother video in and of itself. So I really don't have to hook up any diodes. So let's go ahead and try the original self-rectifying system where I could just hook up a standard neon sign transformer and see what happens. All right, so it's hooked up directly, no rectifier. This is the exact same neon sign transformer that I utilized when filming the original 5-minute FUSOR video 16 years ago. Let's go ahead and close up this a little bit. All right, so let's do this right. Let's go ahead and turn out the lights. I will activate the gate valve and we'll see what we got. And there we go. The 5-minute FUSOR lives 16 years later. Wow, that's impressive. We'll go ahead and let it run for a little bit. I don't have any major ion beams. I do have a bugle jet over on the right-hand side, but that's not going to cause too much wall heating. But the 16-year-old epoxy is doing quite well. So let's go ahead and turn off the gate valve, see how bad our vacuum is. Yeah, so it loses vacuum quite quick. Okay. Some nice little fireworks right there. And let's go ahead and turn it back on. Wow. This should be a commercial for Loctite epoxy. All right, let's go ahead and turn the lights back on. All right. So what I'm going to do now is actually hook a rectifier up to this and just see if that makes any significant difference. So before we go ahead and try the diode, which I'll show you, I do have the diode hooked up right there. You can kind of see it over on the right hand side. Reconnect that. Let's look at wall temperature. So about 130 degrees Fahrenheit. Okay, let's go ahead and turn the lights out again and give it another shot. Okay. Yeah, not much of a difference. Wall temperature, still about the same. All right, we're going to go ahead and do one more, and then we'll close up shop after that. So again, we'll go ahead and turn out the lights. Walk over here. Lights are off. And again, this is just regular air plasma. There's absolutely no deuterium gas or anything like that. This is just a standard demo FUSOR made with 5-minute epoxy that is 16, almost 17 years old. All right, go ahead and open the gate valve. And again, this is performing equally as well as the original 5-minute FUSOR. So in a future video, what I'll go ahead and do is see if I can get the vacuum line seal a little bit better. I will not disrupt or modify the integrity of the original 16-year-old epoxy seals on the end caps or the feed-throughs, and see if I can get this thing down to extinguishment levels. The big issue, though, is plasma heating. In fact, I can kind of see that bugle jet is starting to turn into an ion beam. So I'm going to turn that vacuum down. See, that's the whole issue with these things, because you can get wall heating real fast. And that's going to possibly cause the glass envelope on the vacuum chamber to crack real quick. I am using Pyrex for my vacuum chamber, but that's not foolproof. And again, to point out, I am wearing PPEs, eye protection, all sorts of stuff. So this is not something I would recommend anybody to do if they are not fully protected from any potential implosion hazards. All right, so there you have it. If you got any specific questions about this, feel free to ask, and I will see you all on the next video.